Okay, so here we have y equals 9 over x. This is a rectangular hyperbola. Now, we know we're centered at 0, 0 because we're not shifting at all. What does that mean? That means our x-axis is an asymptote and our y-axis is an asymptote. Are we all okay with that? So again, because I'm not shifting left or right at all, or up or down at all, it means the x-axis is our asymptote and the y-axis is our asymptote. Now, because our numerator is positive, are we going to be in quadrants 1 and 3 or 2 and 4? 1 and 3. Because our quadrants are positive, we're going to be in 1 and 3. So now we need to figure out our turning points or vertices, whatever you want to call them. So now what are we going to do? I'm going to take my numerator and I'm going to square root it. What's the square root of 9? 3. That means from the center point, I'm going to move 3 units in almost every direction here in my first and third quadrants, right? So what does that mean? It doesn't just mean I'm moving 3 to the right. That means I'm moving 3 to the right, 1, 2, 3, and 3 up. 1, 2, 3. From the center point of our asymptote. So that's my turning point for my curve. But now I knew I was going to be in quadrants 1 and 3. So now what am I going to do? I'm not going to move 3 to the right and 3 up anymore. Now I'm going to move 3 to the left and 3 down to be in my third quadrant. That's why I put the plus or minus, like, so do it in the positive direction, do it in the negative direction. So then we're 1, 2, 3 to the left and 1, 2, 3 down. And it just looks something like that. All right, let me show you one that doesn't work out so nice and neat. And then it'll just sort of be an estimation. So if I have 2xy equals 4, do we all agree I need to get y by itself? So now I'm going to divide by 2x. Now when I divide by 2x, can I simplify 4 over 2x? Yeah, so I'm going to be left with 2 over x. The good news is my asymptotes are still what? X and y axis. Right. My turning point or my vertices, they're going to change. So to find the turning point, we're going to take the square root of our numerator. So this becomes plus minus root 2. We need to estimate root 2. So how do we estimate root 2? The two closest square roots, which is 1 and 4. What is that? 1 and 2. Yeah, I'm thinking like 1.4-ish, 1.5, a little less than 1.5. But like really, this is just an estimation. So does it really matter? Are we ever going to be fully accurate estimating a decimal on our graph? No. But what does this mean? It means I'm moving 1 and like sort of like close to 1.5 units, right? 1.5 units to the right and 1.5 units up. So that's like the point. See, let me fix my axes here because I'm sort of in between two lines. So I'm going to say this is root 2, this is root 2, this is negative root 2, it's negative root 2. So it would be like here and here. Sort of not really getting it accurate. Here's 1.5. There we go. So, sorry, we're right here. So it'd be something like that. And did I do this right? 1.5. And then over 1.5. Something like that. All right, are we ready to shift? Are we ready to shift the asymptote? Ready to shift it? It's not so bad. Okay. Which variable for the rectangular hyperbola do we want by itself? We want the y by itself. So I'm going to start off and I'm going to divide by the quantity of x plus 1. So we're going to have y minus 3 equals 4 over the quantity of x plus 1. Y still not by itself. So what does that mean? What am I going to do? Add 3. So now do I have a vertical and horizontal shift? Yeah, so from the old center point, from our like parent graph center point, what's our parent graph center point? 0, 0. I'm now going to shift what? Good. Shift 1 unit left and shift 3 units where? Up. This is for the center of the asymptote. Helen, you with us? Okay.
Oh my gosh, we got long.
I don't know why I did it that long. Okay, so now I'm going to create the center of my asymptote. So now we're going, what am I doing? I was at 0, 0. I'm shifting 1 unit to the left, and then I'm shifting 3 units up. 1, 2, 3. And for the rectangular hyperbola, the asymptotes will always be one vertical line and one horizontal line. So I'm going to draw one vertical line through my center point. And remember, asymptotes are always dashed, unless it's the x or y axis. Okay, now we're still following the same rule, right? My a is positive, or my numerator is positive. So are we 1, 3 or 2, 4? 1, 3, right? Because our numerator is positive, we're still 1, 3, even though our 1, 3 like quadrants have shifted. It's okay. All right, what should I do now? Find the turning point. So we're going to find our turning points. It's going to be the square root of 4. So our turning point is 2, but that doesn't mean it's just 2. What does that mean? It means I go to my center of my asymptote, and what do? Since I know I'm in these 2 quadrants here, I'm going to go 2 units right and 2 units up. I'm going to go 2 units left and 2 units down. All from where, though? The center of the asymptotes. So now I'm going 2 units right, 1, 2, 2 units up, 1, 2. And then from the center of the asymptote, 2 units left, 1, 2, 2 units down, 1, 2. So at this point, do I end up crossing the x and y intercepts? I do. Why did I cross the x and y intercepts? Because we shifted the asymptotes. So it would be fair game for me to ask you, what are the x and y intercepts here? Do we want to go through that? How would we find it? All right, let's find the x and y intercept. Tell me, how would I find the x intercept? Set y to 0. So now we are 0 equals 4 over x plus 1 plus 3. I'm going to add 3 over. So 3 equals 4 over x plus 1. Oh, negative 3. Thank you. So then we're going to get the x out of the denominator. So what I'm going to do is I'm going to do negative 3 times the quantity of x plus 1 equals 4. Distribute in. We are negative 3x minus 3 equals 4. Negative 3x equals 7. So x equals negative 7/3. So this would be the point, negative 7/3, comma, 0. That's the x-intercept. How would we find the y-intercept? Plug in 0 for x. So y equals 4 over 0 plus 1 plus 3. Y equals 4 over 1 plus 3. Well, isn't 4 over 1 just 4? So 4 plus 3 is 7. So what is our y-intercept? 0, 7. Okay, let me give you guys some ones from throughout everything. Actually, hold on, there's one more thing I want to show you. Actually, next class we're going to do a whole class on writing equations, so I could let you guys, would you guys rather practice like yourself sketching, or do you want practice writing equations? Okay, so all of next class we're going to be writing different equations for the circles, ellipses, and hyperbolas based on different information. So today I could let you practice graphing. You guys can try this one. Let me see. Sure. 2 problems will probably take the rest of the period anyway. Graph. Did I do this one already? I can't remember which ones I've done now. Actually, I'll give you a harder one. There you go. So why is this one more difficult? What do you have to do? You have to put it in that hyperbola format, the standard form of a hyperbola, and then graph. How do you put it in that standard form of a hyperbola? Complete the square. And it must equal what number? 1. It must equal 1, and you want to complete the square. I want you to graph the asymptotes and vertices. That's enough. Asymptote and vertices. Can I stop recording? Well, I know. Yeah, we'll stop recording now.